Good day everyone, my name is Mark Redalandama and today uh, I will make my missing activity which is assignment 3 and nag-code na lang ako direct ma'am para para hindi na po talaga siya time consuming ma'am, pati lack of resources kasi ma'am. Thank you. Unordered linear search. What it does. Searches through each element in a list one by one regardless of order. How it works. It starts from the beginning and compares each item to the target. If it's finds a match, it returns to the index. If it reaches the end without finding the target, it returns to 1. When to use. When the list is not sorted, it's simple but not efficient for large lists. Explanation each code. Works on any unsorted list. Second, check each item one by one. The next is slow for large lists because it doesn't stop until it finds the target or reaches the end. Lastly, useful when the list is not sorted. Ordered linear search. What it does. Similar to an unordered linear search but optimized for sorted lists. How it works. It still goes one by one but stops early if it passes the possible location of the target. Since the list is sorted, if an item is larger than the target, the search ends. When to use. When the list is sorted but small. This method is slightly faster than an ordered linear search. Explanation each code. It only works correctly if the list is sorted in ascending order. The next one is if we pass the target because items get bigger, we stop early. Faster than unordered if the list is sorted and target is near the beginning. And lastly, still linear item in worst case but better than basic linear search. Binary search. What it does. A very efficient divide and conquer method for sorted lists. How it works. It checks the middle element. If the middle is the target, return the index. If the target is smaller, search the left half. If larger, search the right half. And lastly, repeat this until it finds the target or the list is empty. When to use. When the list is sorted and performance matter, it much faster than linear search, especially for large datasets. Explanation. Uses a divide and conquer method. Only works on a sorted list. Keeps cutting the list in half until it finds the value of exhausts the range. Very fast for large lists. Time complexity is 0. Interpolation search. What it does. A smart searching method for a sorted and uniformly distributed list, like numbers with equal spacing. How it works. Instead of jumping to the middle like binary search, it estimates where the target might be based on the values. For example, if you're searching for 80 in a list from 0 to 100, it jumps near the end right away. When to use. For sorted lists where data is evenly spaced, it's faster than binary search. In that special case. Explanation. Work on sorted and evenly spaced uniform data like 10, 20, 30, etc. The next one uses a formula to guess the likely position of the target. Can be faster than binary search if the data is well distributed, not reliable for random or uneven data. Test cases explanation. Unordered linear search, I tested an assorted list. The function correctly found existing items like 9 and 1 and returned -1 when the item wasn't in the list. Order linear search. I used a sorted list. It found items like 7, stopped early for 12, then returned the correct index for 1. Binary search. I used the same sorted list. Binary search found items quickly by checking the middle and returned 1 for values not in the list like 8. Interpolation search. I tested with evenly spaced number. It's correctly estimated the position for values like 40 and 100 and returned -1 for values not present. And that's all. Thank you po.